Here we have question number 7, y is equal to cotangent of x, and again this is our domain here, so we want to graph this function, and so let's just do this here quickly. So we have our y-axis, right, our x-axis, and again whenever you have these functions here, these trigonometric functions, always think of exactly how you can write this as, right? So obviously sine, cosine, tangent, those are the more common trigonometric functions. So obviously you can write this as y is equal to 1 over tangent of x, and that will make it easier. So now when we're looking at this problem, right, the idea here is that, for instance, if you take pi over 2, right, you know that tangent of pi over 2 is undefined. So you can really say that tangent of pi over 2 is really just 1 over 0, right? I mean, it's something like that. Now you're doing 1 divided by that, right? You're doing, you have something like this. Now, I think the best way to, put this across is that if you see the tangent of pi over 2 is undefined, right? And we want to find the inverse, right, or the cotangent of pi over 2, cotangent of pi over 2. That is really just 0 over 1, because we are doing the reciprocal. In that essence, we are finding the reciprocal of this value here. That's 0 over 1, so that's just 0. At times what happens is people think that, oh, 1 over 0 is undefined. Well, 1 over an undefined value, it should also be undefined. However, here we're looking more at the reciprocal aspect, right? So we're seeing that if tangent of pi over 2 is 1 over 0, then cotangent of pi over 2 is 0 over 1, which is really just 0. So wherever points for tangent that had undefined values, you're going to see zeros there for cotangent. So those just switch. So now when we're graphing this, right, for instance, we have 0 here, we have pi over 2, right, pi over 2, pi, and then we have 3 pi over 2, 3 pi over 2, and then we have 2 pi. So looking at this, the 0, at 0, you saw the tangent of 0 was actually 0. However, cotangent of 0 is undefined. So we really have an asymptote here, right? Our y-axis is an asymptote. At pi over 2, we see that it's 0, right? Like I just showed you here. For pi, again, you follow that alternating sequence. So for pi, you have an asymptote, right? So it's exactly the opposite of tangent, because obviously those are inverses. So you see an asymptote here, right, for cotangent. Therefore, tangent of pi must be 0. So it's that alternating sequence between zeros and those asymptotes. And for 3 pi over 2, again, you will see that a point over here, and then for 2 pi it's going to be the same as it was for 0, right? There's another asymptote here. So that's your graph here. And again, the same concept applies here. Again, if you recall, the same idea, the tangent of negative x is equal to negative tangent of x, right? So same principle here. So when we're graphing cotangent, right, at negative pi over 2, we have 0 here, right? So, and then when we look at negative pi, right, when we look at negative pi over here, at negative pi we have an asymptote. And again, it doesn't really matter that, it doesn't really matter about the negative here, because again, even if we just multiply an undefined value by an undefined value, or 0 by a negative value, well, those still remain the same. So you still have that 0, you still have that asymptote. Nothing is really changing, right? Because you multiplying a negative by an undefined value or 0 doesn't really alter anything, right? Unless you had like a numerical value of 3 or 3.5, right? But you don't have that. You have 0 and you have asymptotes. So for negative pi over 2, we have this 0 over here, as we have 1 for pi over 2. For negative pi, we have an asymptote, as we have an asymptote for pi. And then moving on, we have, let me just erase this here quickly. So for negative 3 pi over 2, for negative 3 pi over 2, For negative 3 pi over 2, we have a 0, and you see that alternating sequence. And then for negative 2 pi, it's going to be the same as it is for 0. We have that asymptote. So now looking at this, we're again really just connecting the points. And so if you think about this, you know, just because the position of this graph is quite different, right? For tangent, we saw that it was going more like this. However, for this one, you have to be careful because you don't want to do something like this, because if you do something like this, then it really shows that from 0 to pi over 2, cotangent is negative, which obviously it's not, right? You know, tangent, cosine, sine, all of them are positive in quadrant 1, and if you just take their reciprocal, those reciprocals will also be positive in quadrant 1. Therefore, you have a graph that looks something like that, right? And then obviously you do the same, you make the same sketch over here, you do the exact same thing over here, same thing over here. So you have something like that. And then it's a really, you don't even have those half curves right here, because 2 pi, there's an asymptote at 2 pi, there's an asymptote at 0, and there's an asymptote at negative 2 pi. So that's really taking that entire, all of those values here, right? So all of those values are covered here by our curves here, and so we see that they're asymptotes. So when we're talking about the x-intercept, so again, that same concept, where is it crossing the x-axis? Well, we have one at pi over 2 comma 0, at 3 pi over 2 comma 0, at negative pi over 2 comma 0, and at negative 3 pi over 2 comma 0. Our y-intercept in this case is surprisingly none, so we do not have a y-intercept for cotangent effects because it does not cross the y-axis. And then comes our domain, right? So again, same type of format. You're really seeing that domain is the, you know, it's real numbers, again, such that we are talking about this specific domain here, because it has been given to us, and obviously such that x does not equal negative 2 pi, negative pi, 0, pi, 2 pi, and that's it. So we're looking, and obviously you know why, because those are asymptotes, right? At those specific points, at those specific angles, your function is undefined. And then comes your range, and like tangent, your range consists of all real numbers because your graph is infinitely going in both directions, upwards as well as downwards. So in the next lesson I have 2 more graphs, right? Secant of x and cosecant of x, and that will really cover the graphing part of trigonometric functions. So thanks for watching.